Hi guys, we're going to go over lesson 6 over proving angles congruent, and we're going to start with the definition of a proof. All right, so go ahead and fill this blank in. It's proof. This is a thing we have to do in geometry class where I give you a statement to start, and you have to come up with reasons to get to that conclusion. So it's like directions. If I give you a certain place to start, you're going to give me directions how to get to the final answer. Now, within this proof, you have to use mathematical things. So we are going to use definitions, mathematical definitions, properties, postulates, and theorems. Now, I'm going to have to start you with given information. So you will have guidance. This will be pretty easy, but you will have to pay attention because it is something new. This is higher order thinking, and sometimes there is a little bit of a learning curve, but usually everyone does really well with it, and you just got to stick with it. Now, when you're going through these steps, there are things you have to ask yourself. And some of these questions are, what information is given to you, and how can you apply that? And what are you trying to prove? Now, as you go from step to step, you might say, why is this so? Or how can I apply this information? And you might also ask yourself, is there any way this could be false? These are just things to consider as you're doing a proof. And we will practice a bunch of these together. Okay, so I know everyone always says, why do we have to do proofs? Guys, again, it's about learning how to use your brain, using deductive reasoning. And it's just about learning how to do a process, how to go from step A to B to C to D, all logically. And before we do that, we're going to solve for X. We're going to start out pretty easy here. And I'm going to scoot up. We're doing something called the vertical angle theorem. So the vertical angle theorem just says vertical angles are congruent. All right, so we already know this from chapter. So when we use vertical angles, let's look at this picture here. We know these two angles are congruent. So I'm just going to say, hey, let's write an equation. Let's set them equal to each other. So I set it equal to each other. I start doing some algebra. I add x to both sides. And then I divide by 4. And so I get x is 17. Then I plug it back in because the directions say find the measure of each angle. When I plug it back in, I get 51 and 51. Now, does it make sense that they're the same number? Of course it does, because vertical angles are congruent, which means they have the same measurement. Okay, now, working on this next one, let me erase a little bit. Okay, now when you look at this, you have vertical angles. So we're going to set up the vertical angles first. The top and bottom, those are vertical. So if you notice here on the right, I set these equal to each other, and I started doing algebra, and I solved it. I said I did 8x to get 2x minus 18 equals 14, and then I added 18 to both sides to get 2x equals 32, and then I divided to get 16. Now, are you finished? No, because you have to plug it back in. So, because that's what the directions said. So I go back over to the picture. You see the little equation? I'll put them in green. I'm going to take the x is 16 and plug it back in for x. So when I plug it back in, you're going to have to do some algebra. For time's sake, I have it here for you, and you get 142. And for the bottom angle, I plug it back in. Here's my work, and I get 142. Does it make sense that they're equal? And of course it does, because vertical angles are congruent. So, how do you get y? Now, I notice that I have a straight line here. And the straight line is 180 degrees. And so if I put this other angle here, do you guys notice that we technically have like a set of linear pair? Like the little angle plus the little angle equals the big angle, but the big angle is 180. So if the entire angle is 180, and we know that one of the vertical angles is 142, all I have to do, and I did it over here in red, I took 180 and subtracted 142 to get 38. So that's how you get y. And that's the measure of it. Now I decided to skip number 3 for time's sake because it was, pretty much like number 2. For number 4, when I look at it, there are ways to set this one up by vertical angle ways, since this lesson's about vertical angles. And I took the top and the bottom vertical angle and I set them equal to each other. So let's do some quick algebra. Subtract 9x and then add 12 to both sides, and I get x is 14. Now, are you finished? Oh, no, because you have to plug it back in. Let's plug it back in to the equations, and I did here in green. I took the 14 and I plugged it back in on top here, and I get 128. And then I take the 14 and I plug it in for x on the bottom. And when I work it out, I get 128. Does it make sense that they're equal? Of course it does. Now, guys, if they're not equal, then that means either your x was wrong or you plugged it back in incorrectly. Now, how do you get the missing angle? When I say missing angle, I'm this purple here. Okay, so you have a couple choices. Either you could plug x back into the equation, or, and this is a big or, you can realize that this is a straight line. You know the first angle here is 128. So I took 180 minus 128. And when I did that, I get 152. Now, if I chose not to do that, I could take the equation and then just plug in the 14. And then when I do that, I also get 52. So there are 2 ways to get that one. And this is, again, for that angle. All right, so, guys, we are finished with these, and we're going to jump into proofs. Feel free to fast forward it, back it up to any information that you need. Okay. Now, for this one, you know what? I'm going to erase some of these. It might be easier if I do from scratch. I thought it might be faster, but I'll just explain as I go. Okay, so you're going to start with given information. So your given information is your starting point. So you have to start every proof with that information. So when you do this, you have to take given information, start there. Everything on the left is your statements, and everything on the right is your reasons. So this on the right is where you explain it. So how can I explain step number 1? Well, I know this is true. And you know what? We can mark it on the picture. We know this. Actually, let me back up. I know angle 1 and angle 4 are congruent. And my reason is it is given to me. Step number 2. Is that given to you? No. Now, I haven't really talked about what this proof thing is. The proof thing is what you're going to do in the end. It's the whole purpose of it. So, guys, your proof statement goes at the very bottom. That is your goal. So we have to have a goal and the reason why we're doing it. So in the final end, we need to prove that those two are equal. Congruent, excuse me. Now, step number 2, you look at it and some people are like, I have no idea. Well, when you have no idea, you need a plan. So my plan is, if I don't know, I'm going to look at the picture. How do I know angle 2 and angle 4 are congruent? What kind of angles are they? We just talked about it. Didn't we talk about it right above this problem? Right up here. Aren't those vertical? So since they're vertical, let's say we use the vertical angle theorem. So I'm going to abbreviate it, VAT, vertical angle theorem. So the way this works is like from step 1 to step 2, and I go over. And that's where I would put my reason. Now for step number 3, again, you might look at it and go, I have no idea. And then you look at the picture and you say, okay, angle 1 and angle 2, those aren't vertical and they have different markings on it. So how do I know? So when this happens, what you need to do is you need to look at your previous steps. For step number 3, we're going to look at step number 1 and step number 2 that maybe will lead us to step number 3. So I like to highlight, as you guys know if you watch my videos. So I'm going to do this little highlighting thing. So watch this. Here I have angle 1 and angle 2. Look up above it. Do you see an angle 1 and angle 2? I do. I see angle 1, step 1. I see angle 2, step 2. But what do you notice about those? Don't they have something in common? They both have an angle 4 in common. That's no coincidence, guys. This is a property from algebra. This was on the notes from the day before. What algebra property is it when they both have something in common and you kind of combine them together and you kind of leave out the thing they have in common? This is called, starts with a T, if my pen will work, transitive property. Okay, so we will use this a lot. I know maybe the first time we use it, it's confusing, but stay with me. We will keep using it. Angle 1 and angle 3, and you're like, no idea. Look at the, and if you look above, you notice there are no other angle 3s. So let's look at the picture. Angle 1 is congruent to angle 3. So notice I'm doing them in different colors, different markings, because I want you to see exactly what's happening. So the green angles in the picture, what do you notice about them? They're a certain type of angle. We just learned about them today. They're vertical angles. So what do you write when you see vertical angles? You write VAT, vertical angle theorem. Okay, last step. We're trying to prove angle 2 and angle 3 are congruent. Now, if you look at the picture over here, we don't have any markings that show angle 2 and angle 3 are congruent, do we? Okay, so the picture doesn't help us. So let's go back to the proof. And let's see if we can look back at previous steps to help us. So step number 5, I have an angle 2 and angle 3. Do I see that in previous steps? Well, right above it, I see an angle 3. And the step above that, I have an angle 2. Now, do those two equations have anything in common? Sure, they both have an angle 1 in common. So, guys, this is the same thing as before. This, again, is the transitive property. All right, so we just finished our first proof. And I know it's scary, but they will get easier. And the more you do them, the more you're going to be like, oh, we've done that step before, and this makes more sense. So you just have to stick with it. Now, when I do number 2 here, notice it kind of continues on. Now, I give you a bunch of starting information. And if you notice, that's step number 1. You guys remember what you write first. It's a G word, given. Now, as we go through this proof, the proof statement is what we end with. So that should be the last step. So notice I went ahead and wrote this in at the bottom. So that's my goal. I have to figure out how to go from step number 1 to step number 6 and have that answer of 13 equals X. Now the next one says segment addition postulate. Okay, well, hopefully from chapter 1 you remember that. That's little segment plus little segment equals big segment. So let's look at the picture. Can we name this little segment? Sure, that is QR. Can you name the next little segment? Sure, that's RS. And can you name the big segment? And that is QS. So we have to write an equation. The segment addition postulate always shows us we're writing an equation, little segment plus little segment equals big segment. So let's write this out. So QR plus RS equals QS. Now, after I write it out with the names, now if as step number 3 told us here, substitution, we are going to substitute the name out and replace it with the value. So you have to look at it and say, do you have a value for QS? And you do. QS is really equal to 42. So I'm taking out the QR. No, yeah, QR is there. QR is x plus 3. Take out the QR and replace it with x plus 3. Take out the RS and replace it with 2x. And take out the QS and replace it with 42. So, good. We have an equation now. So now we just solve it. Now, remember, you don't have to show your work. You just show the step. So from step 3 to 4, I'm going to group like terms together. I see I have an x and a 2x. So let's group it together. So 3x plus 3 equals 42. So when I combine those, I'm actually going to give you 2 choices. You can say combining like terms, CLT, but normally I'm just going to write I'm simplifying. And you know what? Either one, whichever one makes more sense to you, I want you to write it and it will be counted as correct. Combining like terms or simplify. Now, I'm going to keep going and hope that my final answer is 13. So if I'm solving this, I'm subtracting 3 from both sides. So 3x equals 39. Now, I just subtracted, so this is called the subtraction property. Now, remember, don't write sub-prop because it's confusing with substitution. Now, from going from step 5 to step 6, how do you solve for x? Well, you divide. You divide on both sides. So this is called the division property. All right, so we are finished with this proof. And again, we will continue to do more and more, and it's easier. I know in the beginning it's tough. So stay with me. And if you need to, watch it again. Okay, for number 3, we have a bunch of given information. We have a proof statement, so hopefully you know where to put all of this. Okay, I'm going to see if I can cram all this on here. My pen's not super tiny. So I'm writing all my given information in the blank. And I'm going to take my proof statement and write that in. And since it's my first step, I can say given. Oh my, what just happened? There it goes. All right, so it says substitution. So I need to substitute something. So I'm going to look at step number 1 because that's all I have, and I have to figure out, is there anything in there for me to substitute? All right, let's try to figure this out. Well, on the left, I have this x. That doesn't really help. I have this x. But here I have a PM, and here I have a PM. So I can actually take PM out and replace it with what it's equal to. So I'm going to take the 2x minus 4 and plug that right in there. Okay, so that sounds like a plan. Let's try it. So KL equals 3 times 2x minus 4. Okay. So can we finish maybe working that side out? So what's it called when you multiply that? It's not the multiplication property. It's a different one. Anyone know it? How about the distributive property? Okay. So there's really nothing else I can do. And the picture's not helping. So let's look back at the given information. Do you know anything about KL? And you do. Now, guys, this is something I could have done in the very beginning, but I just now saw it. Do you have a value for KL? We do, don't we? What's the value of KL? You know what? I'm just going to back it up. KL, and I'm circling it, KL is 5x. So I'm going to take KL out and replace it with 5x. Okay, so are you able to start solving this? And maybe I should have, no, it's fine, I think. Yep. So if I solve this, I'm going to actually, now I'm going to show my step, even though I normally say I don't show my step. I'm going to erase it in just a second. I'm going to subtract 6x from both sides. So what's 5x minus 6x? And that is a negative 1x equals negative 12. Okay, and that's how I get that. Now, what property did I use? I moved it over with subtraction. So it's the subtraction property. So how do you go from step number 4 to step number 5? How do I get rid of those negatives? All right, so guys, I mean, this is your call. Are you going to divide by -1 or are you going to multiply by -1? I think most people probably divide each side by a -1. So you're using the division property. So yay, we made it. X equals 12. So we're finished. All right, let's see if we can do this next one. All right, so all of your given information up here goes in the blank. Now, guys, that's a lot. I'm not going to try to cram it. It goes here. I'm not saying it's okay for you to put the arrow. You have to write it. Do as I say, not as I do. That's really bad, isn't it? Okay, so let's take what you're finding, M equals 6. It goes down here at the last step. This is your goal. All right, so even without really knowing anything, you have 3 steps done. And you only have 1, 2, 3, 4. You have 6 more to do. Very doable. Okay, so what do we know? We know x, y is equal to yz. And I know this from my given information, so I'm going to plug it into the picture. And they already plugged the values in, which is super nice. You know xy is 8m plus 5. You know z to y here is 6m plus 17. Okay. Now, it's the substitution. So for substitution, that's normally when you take out the letters and you replace it with the value. So here's what we know in the beginning. xy equals yz. Do we have a value for xy? And we do. It's right here. It's 8m plus 5. Do you have a value for yz? And we do in the givens. It's 6m plus 17. Okay, cool. So now it's all just algebra, which you're good at. So I'm going to move the 6 over by subtraction. When I do that, becomes a 2m equal plus 5 equals 17. What property was that? Hopefully you're saying subtraction and not sub. Okay. Then I have to move the 5 somehow. How do I move that 5? I'm going to, you're right, Subtract again. Subtraction property. So how do you go from step 4 to step 5? Well, I'm getting rid of this 2 by division property. So hopefully maybe that one was a little bit easier and you're going, okay, I can do this. All right, for number 5, I'm really not sure what this thing is on top. It's supposed to be array. I don't know why it looked weird. Anyhow, let's go through it. And I'm looking at the picture. I noticed this A got moved. This A really needs to go at the vertex. So I moved the A. All of my given information, guys, that's a lot. You're going to write it out. I'm going to just draw an arrow because I can't get it all in the blank. And what goes into the last blank? Hopefully you're saying X is 9. Okay, what can we do? When you read this, ray AB is the bisector of angle CAD. Do you realize they're making you know a vocab word? They're making you use the vocab word bisector. So what does bisector mean? Bisector means you're cutting something in half. So I know these two angles are equal. So can you tell me the name of those two angles? Because we're going to apply that word. Let's apply the word bisector and write down the name of those angles. Okay, so the angle on the left is angle CAB, and it is congruent to angle BAD. And what vocab word did we apply? We applied the vocab word bisector. Now, sometimes on the proofs, as you see here, they have a given statement up here and another one, step 3. Sometimes they do this to try to help you with the steps. I just kind of threw everything in step 1. So I didn't realize they had that in step 3. So here's really what's happening. The thing goes in step 1. And then the rest of this would go in step 3. And if you were writing this all on your own, then I would say you can do it however you want. But since it's kind of, you're following and they're helping you, I'm going to try to make it fit. So here's why they did this. First, I applied the vocab word. Oh, you know what I didn't do in step 2? I need to write the definition of bisector. Sorry, I got so flustered with... All right, slow down, Mrs. Provines. All right, so for step number 3, guys, I'm going to put the rest of the information in here, which we already talked about. So for step number 4, I'm going to give you this hint. It's substitution property. It's at least the 3rd time today we've had this. So look back at step number 2. Can we take out CAB and replace it with a value? And we can. 7x plus 2. Can we take angle BAD and replace it with a value? And sure. 5 parentheses x plus 4. So we are going to solve it. So when you take this 5 and you do this little multiplication thing here, it has a special word. It is not multiplication property because you're not multiplying on the left and the right. You're only multiplying on the right. So what property starts with a D has you multiply that out? Hopefully you're saying distributive property. Okay, so on this one, I was gonna say, I think it needs another step. And guess what? There's the other step, guys. It was hiding from me, so I need to move this step down. Okay, so when you're solving step number 5, let's subtract 5x from both sides. And you get 2x plus 2 equals 20. Okay, so this was the subtraction property. And then I want to move the 2 over. So how do you move the 2? So I'm going to subtract it again. Do not write subprop. And lastly, how do you get to the 9? How do you get rid of the 2? You use division. All right, done. All right, number 1 again. All right, so this one's really easy. Really, really easy. Okay, so we have JK is congruent to SH. How do we know that? It is given. How do we know the next step? It is given. Now, so really, you can combine these together. If you were doing your own proof, they wouldn't have to be separate. Now, I think the reason they did that is because they want them so you can easily see what's happening. So in step number 3, where's JK? Well, that's in step number 1. Where's MN? That's in step number 2. Do the 2 equations have something in common? And they do. So guys, this is third time I think we've had this property. Starts with a T. Transitive property. Okay. Number 2, B's between A and D. So when it says that, it doesn't mean that it's like in the middle. It just means it's, hanging out in between. And C's between B and D. So again, do you see how there are 2 given statements? And there are 2 givens. If you were writing your own proof, you could put them all in one given if you'd like. But they're wanting the first given to go in the first blank and the second given to go in the second blank. Now, what you're proving, they already have that as your last step. So guys, we're pretty good to go here. Okay, let's try to figure this out. We have in step 3, it says A to D is equal to A to B plus B to D. Okay, so this is old stuff from chapter 1. Looks like little segment plus little segment equals big segment. What is that called? All right, this is segment addition postulate. All right, now let's try it again. If I have B to D, is it made of BC and CD? Little segment plus little segment equals big segment? Sure is. So this is segment addition postulate. So how do you get the last step? That's the trick. How do you get there? So the picture's not going to help us. We look back at previous steps. So let me get my handy highlighter out. Here's AD, here's AD, here's AB, here's AB. But then where'd this come from? That came from down there. So here's what they're doing, guys. They're taking this and this, and they're saying, oh, BD, I can take BD out and then take all of this information and plug it in. Now, this is not the transitive property because the transitive property is like everything on one side of the equation and everything on the other equation on one side are the same. Now, on the right-hand side, this is AB plus BD, which is not the same as in step 4 when it just says BD. So this is called the substitution property. We're substituting the value in. Do not write subprop. You're going to hear me say that 100 more times today. All right, so I know there are a million proofs here. Oh my. And so I may end up not doing all of them for time's sake. The longest video ever, right? All right, so on number 3, you have lots of given information. they kind of list out here for you. And again, it could have been in on one step, but they try to help you out and say, all right, from step 1, we're going to step 2, and from step 2, we're going to step 3, and they're trying to help you. But again, if you were doing your own proof, you could do it however you like. So let's do number 3. How do we know that HI is equal to IJ? Well, let's see if we have it in previous steps. Here's HI, here's IJ, and do you guys notice they both are equal to the same thing here? So it's the property starts with a T, transitive property. Now, this is a new one today. This property was when we're going from congruent to, or equals to congruent, or from congruent to equals. If you notice, why does I keep doing that? These two steps are practically the same. The only thing that changes is the fact that this one's equal and this one's congruent. So we're just going to say this is the definition of congruence, and you can abbreviate it, just definition congruent. Now, last step. Now, it's all going to have to somehow magically click together. Let's find the magic combination to make it click. Here's HI. The previous step is HI. Let's find JH, which is here. So in step 2 and step 4, do they both have something common? And guess what, guys? They do. So what property is this? Hopefully you know by now. It is the transitive property. Ta-da, finished. All right, number 4. Again, they gave you a lot of given information. That was supposed to be a highlighter. There we go, lots of given information. And again, they put it in 2 steps. You could have put it in 1 if you wanted to. They give you a proof statement, which goes last. So for step number 3, actually, let's look at the picture real quick. D to G is 8. F to G is 8. I know that G to F and E to F are equal. And then I'm trying to prove that D to G is the same thing as E to F. Okay. So again, you're going to get lots of little helper steps. So it will help you a lot. For step number 3, look back at previous steps. Do you see something that will help you? DG? Yes. GF? Yes. Are they equal to the same thing? Yes. What property is it? It is the transitive property. Now, a lot of people get stuck at number 4. And so I actually this year just wrote it in for you. For step number 4, I want you to compare it to step number 2. Do you guys see they're exactly the same except for what's in the middle, the little symbol? So if you're going from congruent to equals or from equals to congruent within the proof, you just say definition of congruent. I don't make you say the word segment. You can just say definition of congruent. Now, the next hint is that we're using the transitive property. So let's try to find it. We have to find the magical combination here to make it all click together. Do we see anything in common? Well, I see those two are in common, GF and GF. So that means DG and EF have to be equal to each other. So DG is equal to EF. Cool. Now, last step. What do you notice about step 5 and 6? These steps are identical. What's the difference? The little sign here in the middle. So what do you write for the sign in the middle? All it is definition of congruence. So again, hopefully this is getting easier as we go through. And then we have this big long one. Okay. Step number 1 and step number 2. The steps should look identical, except for the sign in the middle. So this is definition of congruence. Now this is a new one. We have not had this today. They equal the same thing. This is a property from yesterday's class or last class. When the same property equals itself, this is called the reflexive property. We will use this a lot. Now, the way we use this is once we verify that RA is equal to RA, we can then use that within the other steps. Now, here's why we use it, because F to A and R to N, they both have this little piece here in the middle in common. So does that piece change lengths? It doesn't, of course. So the RA that's part of the one segment is the same RA that's part of the other segment. So, all right, this is tricky. Wake up if you're sleeping. You need to hear this. We're going to use step 2 and step 3 to form step 4. And you might say, what? Now, let's back up. If on step 2, I said we're going to add 5 to both sides, I would just say plus 5 because 5s are equal to 5s. But now I'm saying F, R, and AN, I'm going to add the same thing to both sides, but now it's a RA because RAs are equal to RA. So if I'm adding the exact same thing to both sides, then this is just the addition property. Cool. Now, let's go back to the picture and say, if I have F to A, is it made up of F to R and R to A? Sure. What's that called? It's from chapter 1. This is called the segment addition postulate. Come on, pen. Okay. Let's try it again. For step number 6, from R to N, is it made up of AN and RA? Sure. What's that called? This is segment addition postulate. Now, I gave you all of step 7, but this is a really cool, like, it all clicks together moment. So, do you see here? All of that is the same. You have FR and RA in step 4 and 5. You have in step 4 AN and RA in step 4 and 6. So if all of that's, then these two are also equal. Now, I kind of don't, I think that should be technically transitive. Yep, definitely. That's transitive property. In my honors class, we don't use transitive property, and so I use substitution in my honors class. And so I think when I wrote this, I just wrote the wrong thing. So we need to fix that. Okay, going from step 7 to 8, guys, they're exactly the same. But the only difference is the little sign in the middle. So what's it called when the sign changes? This is definition of congruence. Good. Let's see how many more we have left. 1, 2, 4. 4 more. All right. Step number 1. How do we know step number 1? It is given. How do we know step number 2? It is given. What you're proving goes in step number 7, or the last step, and that's already completed for you. Okay, step number 3 is a tricky one. Let's take a look. Now, do you guys agree? Actually, it's not a tricky one. That was a lie, sorry. From step number 2 to step number 3, the only thing I see changing is this little symbol. It's going from the congruence to the equal. So what's that called? That is called definition of congruence. Now, whenever they give you a vocab word within the given information, which in step number 1, they give you a vocab word, you need to apply it. You always have to apply every single vocab word. So complementary means they equal 90. So we need a step that says angle 1 and angle 2 equals 90. So look what step number 4 is. We said the measure of angle 1 plus the measure of angle 2 equals 90. So what vocab word did we apply? And so we used the definition of complementary angles. If you just write complementary, that's fine. So we need for some of this to click together. All right, so I know step 4, 5, and 6 kind of look the same, but they're not. How's step number 5 different? So from step 4 to step 5, the only difference here is that angle 1 turns into angle 3. So do we know that they're equal? Look at step 2. Are those two equal? They sure are. So we can substitute those out. Let's just write substitution. Now from step 2 to from step 5 to step 6, what's happening? Well, angle 2 turns into angle 4. Are those equal with each other? And they sure are. So we're going to use the substitution property. Now for number 7, if you have angle 3 and angle 4 and they're complementary, isn't that exactly what step number 6 says? I mean, it says angle 3 and 4 equals 90, and complementary means 90. So what vocab word means what we're using? We're using the word complementary, so that is actually the definition of complementary angles again. Whew, okay. Guys, I think this is going to be the last one. I've had enough. I'm getting tongue-tied, and I'm sure you're way tired of doing these. All right, step number 1, given. Step number 2, angle 1 is congruent to angle 2. Well, there's nothing up with the previous step to help me. Let's look at the picture. Angle 1 and angle 2. Oh, those are a certain type of angle. Those are vertical. Let's write vertical angle theorem. Step number 3, let's look at it and see. Angle 1 and 3. Now, the picture's not going to help me. We need to look at previous steps. Okay, you have angle 1 and 3. Well, I see angle 1 and 3 in previous steps, and they both have an angle 2 in common. So this is a case of transitive. Okay, so now in step number 4, I have an angle 4, which I've not dealt with yet. So let's look at the picture. Angle 3 and angle 4 are congruent. And again, I look at it and I realize they're vertical. So I'm going to say vertical angle theorem. And so I need the last step to click together. So I have angle 1 and angle 4. Let's find angle 1 and 4 in the previous steps. There's angle 1, there's angle 4. And they both have an angle 3 in common. So this again is your transitive property. All right. So I know we're finished, yay. Okay. I know I did not do these last 2. If you would like to attempt them, and I would be happy to check them for you. And I think you have plenty of other ones to study if you need to. So I hope you found this helpful. And let me know if you have any questions.